This is part 4 of the 5-part development of Macrosim economic simulation models. We have already built and used Macrosim 1. We introduced the loanable funds model and used that to look at crowding out and a couple of case studies. Now in this video we're going to blend the loanable funds model into Macrosim 1, and it's going to produce Macrosim 2. This is a relatively short video, it won't take long to construct this. Then this will be followed by a longer video, part 5, where we actually use Macrosim 2 to talk about contemporary economic problems. So let's remind ourselves of where we are. We found fault with Macrosim 1, the old Keynesian cross model, because it did not include a financial sector. Because of that, budget deficits always stimulated, were always strong. There was a strong multiplier effect, and there was no impact upon finance markets because there are no finance markets in Macrosim 1. Plus, investment was exogenous, determined from outside and given to the model, and there is no Federal Reserve policy represented, like the ability to increase the supply of credit or reduce the interest rate, even though we know in a real economy that's a major factor. So Macrosim 2 adds a finance model by adding a special version of the loanable funds model to Macrosim 1. So in this model, the supply of funds will consist of the sum of savings plus any increase in the money supply produced by the Federal Reserve System. The demand for funds will consist of the sum of investment demand, all investment is borrowed, and the budget deficit. Here are some new variables for Macrosim 2. Now we have a money supply at the very top. Associated with that is a money supply growth rate, a policy variable, and this is what we'll actually be controlling. This will result in a change in the money supply in any given year. And now, of course, we have an interest rate, as we had in the loanable funds model. And now investment is a linear function of interest rate with a negative relationship, which is to say when the interest rate goes up, investment goes down. And savings is also a linear function of the interest rate, but with a positive relationship. We say it's a linear function in the model because that's how the model's built. We're not pretending that in the real world it's linear. It's going to be nonlinear, but that doesn't really change the model very much. Now we have some new policy variables that the user can set: the money supply growth rate, the level of government spending, and the tax rate. And we're going to have some new sensitivity variables, the elasticities, the slope of savings and investment. So I'm not going to explain very much about the elasticity component because you would have had to have microeconomic theory and remember or understand the elasticity material. And I'm not going to explain it in this. That's beyond the scope of Macrosim 2. But for those of you who know what an elasticity is, this model does include elasticity estimates. Now, here are the equations that we'll be using. It's pretty much the same. We're just combining the two models. At the top, once again, is our national income identity assumption. It's the sum of the three sources of aggregate demand. This is a closed economy, so no net exports. Consumption plus investment plus government. But now, in addition to consumption, investment is also determined inside the model. That was not the case in Macrosim 1. We still have our linear consumption function consisting of autonomous consumption plus the consumption coefficient times after-tax disposable income. Formula 3 is our disposable income formula. It's 1 minus the tax rate times national income. So that would be 0.8, for example, times national income. The deficit, by definition, is equal to government spending minus tax receipts. And tax receipts is the tax rate times national income. Then we move into the loanable funds component of the model. And remember, we saw these equations in video 3, and they were labeled with these numbers. The demand for funds is equal to the sum of investment plus deficit spending, investment being a function of the interest rate as shown down below. The supply of funds is equal to savings plus a change in the money supply, so now we add that policy variable. And then the actual loanable funds model equates the supply of funds in equation 7 with the demand for funds. We also have a simple formula that explains the relationship of the money supply growth rate to the money supply. And the money supply growth rate times the existing money supply gives us the change in the money supply. The change in the money supply is what is going to shift out the supply of funds line, as you can see looking back at equation 6, right? So the change in the money supply is the most important variable in terms of shocking the model. And now we have our investment function, which I represent as having a negative slope in this way, linear in this model. And we have our savings function, which has a positive relationship. And we have at the bottom an accounting identity that must emerge as valid if we have built our model right. And that is that savings also, in addition to being solved as E plus FR, must also equal disposable income minus consumption. And the model is built such that that check, when performed, satisfies the condition that savings does that. Now, we have similar default assumptions as we had before, or solutions. So once again, you may recall, I presented a slide that kind of showed how it all came out for the default. And in that, what we have marked as blue is assumed by the model and is a value provided from the outside. Anything that's in black is the solution to the model. That is to say, when we say that GDP is equal to 2,800, that's the result of running the model. That's not what we assume. Same thing for consumption. Same thing for everything that's written in black on this. And I've added a new color to emphasize that this is a policy-based model. Assumed policy variables include the money supply or credit growth rate. And by the way, I use those terms interchangeably. You can sort of put this in the perspective of talking about the growth rate in the money supply. I actually prefer the more modern approach of referring to a growth in the credit supply, and it is a little different, one between the other. So we'll just arbitrarily call this whatever we want to call it. Government spending, of course, is part of fiscal policy, and so that is a policy variable that we control. And obviously the tax rate is a policy variable that we control. Now here are some of the questions raised by Macrosim 2. So we can ask, well, again, what is crowding out? We know what it is. We saw it in the third video, but how is it represented in this model now that we have everything put together? And again, as we investigated in part 3, how is crowding out offset by monetary policy in this full model, or is it? And then finally, we ask, what are the policy implications of what we're discovering here? And we actually get some good results for that, I think. And then, although we're going to talk about this a little bit, not very much in this class, because again, I can't assume that you know what the term elasticity means, but what happens to our results when we adjust the sensitivity variables of savings and investment to interest rates. And that's the elasticity issue. And I'll talk about it briefly here, but that actually deserves a separate treatment. I decided not to add it to these because it would literally require another 10 to 15 minute video. And I think what I have here is enough. Finally, and far more important, because we didn't get this in Macrosim 1, what are the feedback or secondary effects of manipulating policy variables like the money supply growth rate, tax rates, and government spending? Now, what I'm saying there, or asking there, may not be very clear to you. When I say what are the feedback effects or the secondary effects, let me show you by a diagram what I mean by that. Now, in Macrosim 1, remember, when we cut taxes, we really strongly stimulated the economy. It was more effective than increasing government spending, at least given the example that we used. And so the chain of effect here can be sort of represented by these 4 variables. When we cut taxes, that led to an increase in disposable income, because of course disposable income is 1 minus T times national income. That in turn led to a substantial increase in consumption, and that in turn led to a very substantial increase in national income. And so there is no secondary or feedback effect in Macrosim 1. And this is what Macrosim 1 said. But when we looked at the loanable funds model, we realized that if you cut taxes or if you increase government spending and don't match that with an increase in taxes, then of course there might be a crowding out effect from that. That can't be represented in Macrosim 1 because investment is exogenous. It's outside the model. So Macrosim 2 has the following feedback effects. In addition to the chain of influence represented along the top line, what happens to GDP or national income when you decrease taxes without cutting government spending, now in this model we realize there's actually a secondary effect as well. The top line is still the same. Taxes go down, disposable income goes up, consumption goes up, and that increases national income. But because we reduced taxes, the deficit goes up, which increases the demand for funds. The interest rate goes up, investment goes down, and that pulls national income down. So therefore, what happens is going to reflect the net effect of those two. And that's why Macrosim 2 is a much, much better model than Macrosim 1. It allows us to capture secondary effects, and the final impact upon the desired final variable, national income growth, is ambiguous until you actually run the simulation and see how it turns out. Well, that's all we need to say then about this model. Now we're prepared to actually run the model and use it in a number of applications. So let's get to that next.